Well, the first thing I'm going to mention is we do have some seniors in here, but we have a lot of students that are not seniors in this class. So I should mention that open enrollment is now there for virtual school. So if you want to be in virtual school again next year, enrollment is open. So this week and next week. So you got until next Friday to enroll. I want to put go to our website. I'm going to put the information in Google Classroom here this morning for the link for that. If you haven't already done it, I know several people already signed up. It opened up Friday was the first day, and there's been a lot of people already signed up Friday. But if you haven't done that yet, I'll post that link. Like I say, you got this week and next week to sign up for next year's virtual school. Of course, you seniors, you got other plans next year. You're going to be in high school. At least I hope. All right, let's look at what we have this week in Foundations of Programming. So I go to a grade screen up here to look at what's due this week. See, today is the 6th. So that was due yesterday, the decoding ASCII assignment, which wasn't too bad of a program. Supposed to come up with a famous quote or saying or whatever you'd like, and you encode it, print it in ASCII, and then you decode it back and print it in actual readable letters. So this week we are in 5.03, procedural and object-oriented programming. So this week we'll just have a multiple choice assignment after that. So let's look and see what we need to know about procedural and object-oriented programming. 5.03, right there is our lesson. We'll go through this together here real quick. All right, programming design approaches. Right, there's different ways to program, right? So let's talk vehicles first off. Sedans, SUVs, trucks, campers, they're all vehicles, right? We know that. They've all got wheels, doors, brakes, taillights, air conditioning. Well, if you're lucky, air conditioning. Air conditioning is pretty much a must-have in this part of the country anyway. So most all cars around here have it. So, but there's some commonalities there, right? Because they do all have the basics. That's the same. They all have the basics. That's the same. But they have some different things that make them a different kind of vehicle. But each of those pieces make them a vehicle: wheels, doors, brakes, taillights, all this stuff. They have different features, different colors, right? Some have different specific uses. Like if you got your smart car, you're probably not doing off-roading, but there are vehicles that are great for off-roading. Pickups have a different purpose than a smart car, all that kind of stuff. All are considered vehicles, but they just have different things. Vehicle manufacturers could create each one from scratch, right? Which would be very expensive if it was all done from scratch. Deciding on the color, the size, the engine individually on it, or then create a template and just mass produce it like they do in the factories. They just pump out one, just changing certain little things to make them different to where they can have a bunch of different cars out there for you to buy. So, but what about airplanes, rocket ships, horse-drawn buggies, right? Those are all vehicles, a different kind of vehicle. So what do they have in common? They transport things. They require a driver, which is becoming a little less common, right? They're starting to have self-driving cars out there. There's a whole lot of them out there on the road. They go to and fro. I like that. We don't use that phrase enough, to and fro. So remember how we're talking vehicles? Well, what we're really talking about is program design approaches. Same type of thing. We can do them from scratch with tweaking certain parts of variety. They all have the same components in there, but there's a lot of difference. So we're going to talk about this week, defining procedural and object-oriented programming, comparing them, and then discussing the advantages of using object-oriented programming. So let's move on to page 2 here. Procedural versus object-oriented. So the term design approach refers to the way a programmer thinks about his or her code. Right? The choice of approach can vary by project or by programming language, but there's two main design approaches. So you got procedural programming, which we can hover our mouse there and it says a definition, a programming design approach that divides well-defined tasks into modules, functions, or procedures. Procedural programming. It breaks it up. So when you learn to program, you often start with a high-level description of what you want to do and then break it down, right? kind of like your pseudocode. You're going to start with the big stuff. They're going to break it down to the steps you need to do it. They break it down step by step, and then the functions needed. All right, so you do this when you write programmer-defined functions, because we know how to create our own function. So we did some graphing that said define star, right? That was a function that defined and how to print a star in Python. So programmer-defined functions. You take it one step at a time. Decide what it'll do, what it's going to be called, how it will work. Then as you go along, you write the code needed to do that. So manufacturing vehicles from scratch would be like procedural programming. The other design is known as object-oriented programming. It's a programming design approach that focuses on objects rather than functions, often referred to as OOP, as opposed to OOPS, which is when you made some mistake. No, this is just OOP. In OOP, a programmer thinks in terms of objects, which is an instance of a class that encapsulates its own attributes and behaviors, objects rather than functions. So they're defined as using the class and are parts of a program that carry out certain actions and interact with each other. So like manufacturing vehicles from a template is similar to OOP. So let's take look at the differences here. There's the description of each, which we looked at above. The application would be procedural programming, known as top-down design. You start at the beginning and you work through every step. Where object-oriented programming uses classes to define and create objects for a program. You'll write code and have objects interact and perform the actions. We'll look at this a little closer because right now it's kind of a confusing comparison. Languages. Procedural programming is the early programming languages like Fortran, COBOL, C, BASIC. Those are the programs I learned programming in. I learned the BASIC. When I was in high school, our classes were in the BASIC programming language. In college, I had Fortran, COBOL, and C, in addition to more BASIC. The object-oriented program today, most of today's newer languages, such as Python, Java, and C++, are object-oriented. So a lot of what we're doing is object-oriented programming compared to the old procedural programming back when I was in school. Here's an example. On the left, procedural programming. If you're planning a party, the procedural way, you would list all the steps that need to be done. 1, send invitations. 2, buy food. 3, decorate. 4, make a playlist. 5, prepare games. Where on the object-oriented programming, the OOP way here, you would call an object party planner, and it would be the same thing you used for your last party, and you would just plug it in and let it do everything that it did last time. It would be already built around that object. The object's party planning, and you have this procedure built for that, and you just plug it in this time. Oh, I'll use that same one I've used before. So while procedural programming is a logical way to think about writing code, object-oriented is pretty intuitive. Once you define something, like this party planner, it's easier and faster to create new objects instead of another party because you've already got a procedure in place for that. It does require more planning up front because more objects mean more complex programs. So let's dig into the nitty-gritty. This is one of those things where you set it up at once and it saves you time later. It may take more time to build it the first time, but then you can reuse it over and over. So most things you encounter today are objects, like cars, furniture, your phone. They're all objects. For each object, you can customize the way it looks, customize it. You get your car look different than everybody else's car. You can customize cars. You can customize furniture. You can customize your phone. There's all kinds of different phone cases, and there's the software that you can make your phone look different on the screen and all that stuff. So you can make the way it looks, its features, what it can do. We define objects by their different attributes, behaviors. So this can be simulated with program code. So let's look at this phone image, and there's all these little pluses on here. So let's look at what it has on there. So if we look at this one, right next to the add photo button, this is a constructor. This refers to code that allows you to create a new object. Because add photo would be constructing a new photo. It's a special method used when a new instance of a class is created. Right? The initial values are set. It's like adding new contacts in your phone. Right? That's constructing something that you didn't already have. Let's turn that off. Class. This refers to a template used to create new objects. Right? Think of it as a blueprint that has existing characteristics you can use when creating new but similar objects. Like every time a new contact is created for your phone, it uses the contact class, right? It's already got a template for all the information you would want for a new contact. So you don't have to start from scratch figuring out what your contact needs. You've already got a template. So we have another instance. Many instances of a class can be created, right? For example, an object is an instance of a class. One individual contact on your phone is an instance of a contact object. And you can create many, many, many contacts, right? You can just keep creating more and more from your template that you've already built from your OOP. Initializing. This refers to what the constructor will do when you use it to create a new object. Right? It will initialize the object in the program. So when you create a new contract, all of its attributes will have initial values. Here's next to the mobile number, attributes. This is the features of the object, right? Like, so you have to save a contact. One of the features you're going to save is the phone number. That's what you need. The attributes of a contact might include a phone number, email address, or picture, or all three. Attributes are often nouns and adjectives that define the properties or characteristics of the object. Don't worry, we're not going to get too deep into English class. We're just talking a little bit about nouns and adjectives. Ringtone, waves. It's a behavior, right? It's known as a method. It refers to the actions an object performs. So when this contact contacts you, Monty Python, you're going to have a different ringtone set up just for that contact. Like, I have a different ringtone for my wife than regular calls. So you can set a specific ringtone or vibration pattern to a specific contact. So I won't tell you my wife's ringtone. Here's a programming spotlight on somebody that's been part of programming. Mark Zuckerberg, born in 1984, least likely to succeed. I don't know if that's true. They may just be having some fun with this here, Monty Python style. Dropping out of college at age 19, his second year of college. It would seem he was not likely to succeed, but we know that's not true. He co-founded Facebook. He began programming at the age of 12 and became a billionaire at the age of 23. The Facebook interfaces makes full use of object-oriented programming, right? Classes to create new objects, user profiles, reaction buttons, notification features. Those are all object-oriented. It just pulls up that same code and repeats the action over and over again for each new user or each reaction the user does or comments they add. Let's talk about the advantages of OOP. Object-oriented programming has a lot of advantages. It's reusable code. Once you write a useful class from one programming project, you can reuse that class in another program instead of starting from scratch. If you've done one of these programs this semester that you've already built a function that performs some action, and you got another program that needs to perform that action again, just go grab that code and bring it over. All right. If you create a class for a deck of cards, you can reuse it again for any program that you need a deck of cards. Right? If you make a game that uses a deck of cards, you need to create that process that puts the deck together. You can just copy that code over and use it again. Inherited traits. Programmers can create a new object that inherit traits from existing classes. Means they can add new features to an object without having to start over from scratch. Save a lot of time and effort. All right, so if you got one that creates a deck of cards, but now you want to do a pinochle deck, the pinochle deck is smaller than the deck of cards. It throws away the smaller cards. So you can go in there and just delete the cards you don't want in your pinochle deck. So if you create a vehicle class that has all the basic functions of a vehicle, it moves, it carries people or things, starts and stops, you could build on that to create more specific vehicles like convertibles, bicycles, semi-trucks. The flexibility. Programs created using OOP are easier to develop because of their flexibility. Objects can be used in a variety of ways, got different behaviors for different purposes depending on the program. Here's a good example. If you create a class for your bank account, many bits of information, like your name, social name, and birth date, are needed to open an account and get a loan. But for the simple transaction like making a deposit, only basic information, just name and account number are needed. So your bank account class can work for all of these. Create that program can be used over and over again every time you interact with the bank account. Easy to maintain. They're written modularly in objects. Like when you did that define star, you printed 3 different things in the menu several programs back. And so it's a module. Each one of those is a module. So you can modify maintain those and change things just about that one module without having to go through the whole program. So, example, if you're planning a meal and you burn the cupcakes, you don't have to fix the cupcakes. That's the whole meal. You got to make more cupcakes or substitute different dessert in. And OOP objects can be maintained separately, making finding and fixing problems easier. So that is the difference between procedural and object-oriented programming. So we read the lesson. Now you just have the 5-question quiz, which we can look at real quick. I think it's just 5 questions. Yeah, just 5 questions. It's all about the differences. So easy assignment this week. If you are behind and haven't got some of the assignments in, this would be a great time if you get that done, since we just have 5 questions this week. So those easier weeks. Because you know that means next week we'll be back to writing a program, and then we've got the exam the week after that. So get these things turned in. So, all right, any questions on procedural and object-oriented programming? All right, it's pretty straightforward, just kind of learning the differences, trying to understand which works easier. I mean, object-oriented is obviously a newer style. The procedural, all the programming languages that mentioned were older languages, like it had C, where now we're all the way up to C++. There's been more generations of that language now, so no one uses C anymore. They use C++, C++, those other languages. So, all right. Well, if anyone needs any help with any of the past programs they've done, you can certainly hang around. We can look and help debug or whatever you need help with on that. Otherwise, have a great week. Don't forget, virtual enrollment's open for you guys that aren't seniors.